Okay. No, it doesn't.
You have to tell me that I have to stop. It's now it should work.
Okay. It should just.
Giving Niklas the address. Oh, Niklas is in. Great.
Okay.
Niklas, can you just say something? In our research group, we have this idea that if a new person joins who has the same first name as somebody who's already in there, they have to choose a new first name. Nope. So he might not be hearing us. Yeah, let's spend a minute to get this going. So can you count till 100, please?
Count 100.
Yes. So Niklas can hear whether.
All right. One.
I can hear you.
Yes. All righty. Perfect. I only got to 2.
So you can also switch on your video by clicking on the camera icon.
Yes, work.
Perfect. Thank you. Okay.
Okay, I guess we can get started then. So, welcome everyone to the Thing to Thing research group meeting. We are now at the IETF 121, but of course this is an IRTF meeting, as you well know. My name is Ari Keränen, yes, Karsten Burman, we're both chairs of the group. And as usual, because these are IRTF meeting, the note well applies. Short version, you may be recorded, actually you will be recorded if everything works fine. Be nice to each other, and the IPR guidelines do apply. You find the longer version of the note well on intellectual property, on recordings, and on privacy and code of conduct on the slides. As usual, if you have any questions, you can read the RFCs or ask from chairs. Very happy to help you here. And quick reminder of the goals of the IRTF. So here, unlike at the IETF, here we focus on long-term research issues that are related to the internet. And then it's the IETF where actual standards work is done. So we don't do standard development here, but we focus on the research aspects. Although we do work, of course, very closely together with the IETF and have a bit more details that coming in a moment. Quick administrative here. So always welcoming note takers. I will be taking notes, and thank you, Chris, for volunteering also taking notes. You can reach the Meetico chat also via Zulip or via the Meetico online tool. And if you're not already a member of the mailing list, please do subscribe there. That's where we usually announce all our activities, and there's also some discussion on the activities ongoing. So that's the best place to keep up to date on the activities. Also, we do have a GitHub repository traditionally for all the meetings, and there's the link to the current meeting where you can find the latest details and materials. A quick reminder of the Things in RG scope and goals. So the idea in this research group is to really to look at the research on turning a true Internet of Things into reality. And in particular, our focus has been on these low resource nodes or constrained nodes. It's not the only thing that we look at, but it's a key thing to make sure that also those low resource nodes can be part of the bigger internet and Internet of Things. And we do focus, on the other hand, on issues which have opportunities for IETF standardization. And usually we start our work at the IP adaptation layer, maybe peeking a bit to the radio details, but then going all the way up in the stack towards the application layer, looking at architecture, APIs, data management, device management, and then of course, and in particular, including security. So give a quick example on how we work together with the IETF. So where we do the open research issues with IETF potential in the IRTF side. For example, we've been working close together with the core working group on the protocol engineering or RESTful environments, and the ASDF working group on engineering format for IoT model convergence. And then, for example, there are also groups on the more operational area, like IoT Ops, where it's a discussion of operational issues related to IoT, and we all very often work together. For example, if we find issues that are more researchy in the working groups, the discussion often comes to the research group, and also the other way around. Once things get more mature and we see the potential how to go forward on the IETF side, one of the working groups typically picks up the work from there. And when it comes to particular IETF and IRTF work in the IoT space, so IETF looks at these communication technology standards for IoT, originally starting from these Internet Protocol adaptation layers, getting IPv6 working on the IoT devices. But then has been further a lot of work, for example, transfer protocols, CoAP in particular, profiling transport protocols, making TCP work on this device, making DTLS work well. And of course, more recently, a lot of work on security mechanisms, application data formats, and data modeling. Altogether, there are more than 15 specific working groups since 2005. And also at the working groups, even beyond those 15 plus groups have been, of course, participating to the work on the IoT standards. And here at the IRTF side, our work has been fostering the research that can inform such standardization. So in T2TRG, of course, very much focused on the IoT topics, but there are also other research groups, for example, CoinRG, that has been having IoT topics on the agenda. And that's how we've been working together. So quick status update of the T2TRG group documents. In the past, we have published 2 RFCs. Right now, we have 4 drafts getting close to ready for publication. We have this document on guidance on RESTful design for IoT systems. Actually, has been going quite some time, almost the whole lifetime of the research group. The authors here do feel, I mean, there would be things we could add there, but maybe it's time to really focus on publishing this document. So we will very much welcome your reviews on it. It was just recently updated with a bunch of smaller updates. So if you haven't read a recent version of the document, please give it a read, send your comments to the mailing list. We hope to be moving towards RGALC pretty soon. Then there's a document on amplification attacks using CoAP, quite specific on the security side. Here, the authors think that there is just one more update is needed on the mitigation side, and then that document would also be ready towards publication. We also have a document on termination process for initial security setup of IoT devices, basically how you onboard IoT devices. And it's a survey on how different ecosystems and protocols actually do it. There, a bit more ecosystem-specific input is needed, add more details, but that's also moving slowly towards publication. And finally, we have a taxonomy of operational security considerations for manufacturer installed keys and trust anchors. Also here, there are some opportunities for more details. A draft lists a few areas of such. We already discussed among chairs. It actually would be good to lift those a bit of discussion on the mailing list going forward. But that's also a document you should be very much reviewing now. Then finally, a quick report on the hackathon activity. So we often have various activities at the IETF hackathons that are in the T2TRG scope. This time there was a hackathon project. It was originally called NIPSI and ASDF, but it was a wider scope in the end, so we called it SDF at Work. Here, the key idea was around working around SDF, the semantic definition format, and we had 2 different activities around that. One was using SDF for IoT device onboarding, and there are 3 related technologies. Look at the IETF. There's the device schema from the scheme that would be enabling device onboarding in this context. Then there's the NIPSI, application gateway for non-IP devices, specification and protocol that is done at the ASDF working group right now. And then SDF, the semantic definition format that actually describes the device capabilities and how all these different technologies can work together to onboard IoT devices to wider systems. That was the key idea here. And what we did come up with is a new SDF extension that can be used for mapping non-IP devices, such as BLE and ZigBee devices. How we can express that information in SDF definitions and use that to on the APIs on the NIPSI side. And it's going to be discussed in much more detail on the ASDF working group coming right after. And also we did discuss that there's potential to use the similar mechanisms in mud and scheme extensions. So you'll be hearing more details about that soon also. Then the other topic on the hackathon was converting matter models to and from SDF. So key idea of SDF that you can actually go between different ecosystems, and we have a variety of different ecosystems already supported, but Matter wasn't one of them yet. But we had Niklas Meyer did a great job on that, just implementation on towards the Matter ecosystem. But we will hear much more details on that in Niklas's presentation quite soon. And finally, of the upcoming meetings and activities. So this is now what we call a summary meeting. So we used to have more of these during the IETF weeks, where we give an update on the bigger picture, what's going on at the RG, at various different activities, and have a discussion of a few specific items. But then the more specific work typically happens on these interim work meetings that we typically have online. Then we're also looking at other meeting opportunities. So for example, these in-person meetings co-located with related activities. We had a really good experience with this lightweight IoT security hackathon in Paris in May. So very much looking forward to have similar activities. So if you are organizing an IoT related activity and you think there could be a potential for co-locating and in the RG meeting, please do let us know. We're very much open to such activities. Also, we've been very much interested in co-locating with academic conferences. We haven't done that nearly as much as we wanted. So, but if you are, for example, organizing committee of one of such conferences and you think there could be a potential for co-locating in the RG meeting, please do let us know again. Very, very much open to that. Also, we do think of, at least at the Madrid IETF, we could have a similar summary face-to-face meeting as we have today. It might be that not all of us chairs will be able to make it to Bangkok IETF. Still a bit open, but definitely Madrid would be a good opportunity for a next face-to-face. And then finally, a quick overview of the agenda for today. So now we are at the intro section. Next, Karsten will be giving us a bit of an overview of what has been going on at the Thinking Research Group, depending how you count, whether it's 9, 10, or 11 years. Following that, as I mentioned, Niklas will be giving a presentation on converting interaction models between SDF and Matter. So that's work that Niklas did as part of his bachelor thesis. And then Manoj will be giving a presentation on sharing data models between CNML and CoreConf. So I mentioned about this data model conversions being one of the topics, and that's kind of a very specific example here. So that's our first cluster around data models and interoperability. And then we have a second cluster around security topics. And there, Marco will be starting with an overview of architecture and components for secure group communication with CoAP, how we can put different components together actually to make a bigger system there. Chris will be giving a presentation on the building onion routing from core building blocks. And then finally, Michael Richardson will give us a summary on the NIST activities on the trusted IoT device network layer onboarding and lifecycle management efforts. That's a mouthful. And finally, if we have a few minutes, we'll be doing a wrap up before ending the meeting around 11:30. Any questions or comments on the agenda, or shall we get going? Okay, in that case, thank you. And Karsten, you're next.
Okay, thank you. So in the life of anything that goes on and on and on, there are those events where you start thinking, shouldn't we be celebrating something? And since next year will be 2025, and this group got really going in 2015, we thought, okay, we might have some 10-year stuff. But then I thought about it a little bit, and actually, I think we already have had 11 years of T2TRG. And the reason is that when we finally got the CoAP protocol approved in July 2013, this was kind of an interesting experience. So we had this protocol, and yes, it worked. We had interop testing going on and so on. But what is actually the way you build IoT systems with that? That was a question that immediately jumped into the foreground. And we wanted to work on making CoAP and the other IETF IoT specs work in reality as a complete system. Not because we do system standards, that's what the IETF is for, but because we just wanted to make sure we have experience in building systems out of the components that we have standardized. And by the way, you might notice that we have about 15 working groups in the IETF that do something with IoT. So this is really a tall order now, but it was what we wanted to do from about 2013. And that's where the 11 years thing comes from. And we thought about how can we organize this? And you see, this is a slightly yellowed slide from 2013, where we started thinking about why do we want to have a research group? And this was the point in time when we had this full stack wave of IoT standards, and we saw all these consortia coming up, and we wanted to help these consortia coming up with approaches that made sense in the light of those standards. So this was meant to be targeted research based on actual usage of standards. So as usual, it took about a year until these ideas took foothold. And finally, in February 2015, we started the research group as a proposed research group. That's a tradition in the IRTF that you give a new research group a year or so to prove that it is viable. So we started as a proposed research group and right away started meeting at IETFs, at W3TPAC, WCTPAC, and other places. Other SDOs came later. And by December 2015, we were an active research group, and somewhere in between, Ari joined as a chair. So this is really the reason why we could be talking about 11 years of T2TRG. We actually started this work in 2013. What have we done? We have 2 RFCs published, with this, which is pretty meager for 9 or 10 years, but we have 4 more getting ready for publication, and which Ari just listed. And also, I think it's pretty interesting that we have a large number of internet drafts sitting there that just document some approaches, some experiments, some ideas that we may not want to develop, not all of them certainly, into RFCs, but that are still out there as internet drafts, as written up documentation that people can look up. And we were really surprised to see it's 45 of them now. So it's an interesting body of work. And this morning we had a discussion that we probably need to do a table of contents for this and cluster them a little bit and so on. We have done a lot of work on information interaction modeling, and this is essentially what became the ASDF working group in the IETF. We had our activity called WISHI, which is bundling this information interaction modeling part. We had the original WISHI workshop in 2017, and I'm not sure that number 5 hackathons is still true, because the SDF work was kind of a hackathon again. So don't believe those numbers, but a number of things happened. We did a lot of work with other SDOs, OCF, OMA. Matthew just asked in the chat if we can do more with OMA. Yes, we probably have to look at what are the problems we should be working on now. W3C, of course, Bluetooth SIG, which is difficult because of the organizational structure, and most recently the 1DM liaison group that essentially kicked off SDF. Okay, so I don't want to make this too long talk about the past. The impact is, of course, communication between these SDOs, not just with us and the SDOs, but also between the SDOs. Communication with implementer communities. The Riot community has been really useful. Some of the co-op software is being maintained by Eclipse, and so on. Within the IETF community, we have challenges bubbling up from working groups into the research group, things that the working group cannot do because it would detract from their actual engineering task right now, and maybe has a longer timeline. And we have things bubbling down from the research group into working groups when it's time to do that, like it was with SDF and the ASDF working group. So today we have two major legs we are standing on. One is the information interaction modeling that I already have talked about enough. Maybe I should mention that the Yang ecosystem, of course, is an interesting ecosystem to look at. There are some interesting research questions there. Yeah, this is definitely going on, and new work is happening in the IETF that we may want to support by doing research surveys, experiments, benchmarks, and so on. So this is one part. The other, in this area, we have this model you may not be familiar with when you don't live at the application layer. But typically when we have a data format, we have three layers. We can look at the data format. We have the information model, which really is about semantics. What is the data format trying to tell you? What is the vocabulary? Do we have taxonomies that go in there? Do we have ontologies, maybe semantic web and so on? So this really is about meaning. And then we have data models, which are descriptions of what data we are actually going to be interchanging. And these data models are usually derivations from a generic data model like JSON. JSON is a generic data model that can do certain things and cannot do other things. So if you want to do those other things, you have to map the information model to the data model. And then finally, a data model, a generic data model in particular, comes with a serialization. So we know how a JSON file looks like. So concrete syntaxes, marshalling schemes, message transfer formats, encodings. These are words we use in this layer. So we look, in the research group, we mostly look at information models and data models because we take serializations for granted, and we have other working groups working on that. And what really motivated us to take up this work was a discussion we had in 2016 in an IAB workshop about working with information models and data models in the IoT space. And this was what we are seeing ahead of us. So we have all these different data modeling efforts. And in the end, of course, we have to translate these models. So if we connect a Bluetooth sensor, temperature sensor with a Zigbee thermostat, we have to convert not just have to provide connectivity, we have to convert the data models. And we know how to solve that problem by coming up with a hub in the middle. So we translate everything to that hub, and that hub to everything, and that's pretty much what SDF has become. This is essentially just looking at static models, and some 8 years after this workshop, maybe it's important to think more about derivation activities. So for instance, we could have a generic data model like SDF. SDF is a way to write down generic data models, and we could derive more application-specific data models. So for instance, somebody could write a Yang model that is a derived model from something that is initially described in SDF, because Yang is great for very specific things that don't evolve very much, and SDF is solving a different problem. So this is the horizontal axis here, and there's also a vertical axis, which is that the generic data model gives you a way to do instances. You need some representation format for those instances. So SDF doesn't come with an instance format yet, and that's certainly something we want to work on. The W3C Web of Things activity has an instance description. It's called thing description, and they have a generic model, thing model. But the instance derivation they're using is pretty pedestrian, and we may want to look a little bit more into that subject. The other thing that we are doing is security, the other leg we are standing on. There are also data modeling issues in security, but the model actually goes a little bit beyond that, because there are participants of a security dialogue, and these participants have roles, they have objectives. And if you do not capture the objectives that you have for certain communication, then you have no idea whether you are secure. So we have done a few survey style documents. Arias already talked about that. And today we will have two talks that really go into the architecture level and discuss how do we build certain things out of building blocks, which building blocks do we have for secure group communication, and can we use our building blocks for secure communication in general, for not disclosing the identity of participants. I don't have a beautiful picture for security, but this is the picture that everybody of us looked at very long before we finally put it into RFC 8576. So this just points out that a thing has a life cycle, and you have to look at various activities during this life cycle, not the least software update. Finally, we have a new thing coming up, which we haven't really defined in a lot of detail. The only thing is it's not new. IoT in the IETF always was about power usage. So when people come to us and say, you need to do sustainability, then you can say, oh, we have been doing that since 2005. And so that's, I think, pretty well understood. Working groups like SHIC work on having very small representations of communication items, of messages, and so on. We may want to look more at the system and instead of just a single communication path. The other thing that we contribute a little bit to is not wasting embodied energy in a device. Laurent wants to say something?
Yes, for sustainability, I think it's not only energy, but it's also that you produce a lot of devices that have a specific task, and then when you want to change, you throw it and you build another one. So maybe your reusability should be also an issue in that agenda.
That's essentially what I was trying to say here. I mean, energy is an important point there, but waste is not a good thing. And so how do you update software? How do you reuse? How do you recycle a device, give it a different use? That's certainly something we will continue to look at a lot. And there is a proposed research group called Sustained that will lead the effort in general. Alex.
Yes, thank you. I see the mic is open to react, and yes, fully agree with what Laurent, what you said. And I think one other point is actually interoperability. You know, all the things that have been done with the semantic descriptions of devices and like the technologies that come out of this of the IETF and this research group, they allow interoperability and devices live on for a long time compared to like proprietary devices that, you know, when the company that just goes bankrupt or something, they just get bricked all over the place, right? So very different approach, and this is related to sustainability in big time for me.
Thank you. So that's why this says the right to reuse, which is maybe a phrase we need to work on. Okay, that ends my little overview and my view into the future. And now we will have 4 talks, 2 remote talks in the data model space and 2 local talks in the security space. And in a second, I'll change the slides for Niklas.
Okay.
And I would just like to thank you for all your efforts over the many years, both to the chairs and to the rest of the group. I think it's been a very successful group, and looking forward to more years.
Thank you.
Okay, Niklas, you should see some controls on your screen that you can use for advancing the slides. Just click on the numbers.
Wrong, Nicholas.
So we are seeing your first slide.
Yes, but I don't have any controls currently.
Okay, so maybe you just. Oh, I gave it to the wrong Niklas.
There are 2 of us.
Yeah, let me fix that.
Yes, now I have them.
So you have control?
Yes.
Good.
Yeah, welcome to my presentation. I'm Nicholas, and today I'm going to present to you part of my bachelor thesis that I did at the University of Bremen. And the title of this presentation is Converting Interaction Models Between SDF and Matter. And with that, I'm going to give you a quick little introduction into what Matter actually is. So Matter is a relatively new IP-based connectivity standard that was specifically designed for use in the smart home, and that set itself some main goals, one of which is to increase compatibility between devices, especially devices from different manufacturers. For the data model, Matter utilizes a hierarchical structure with nodes being at the top of this hierarchy. Nodes are addressable units that are addressable for Matter devices inside such a Matter network. Nodes themselves consist of 1 or more endpoints. Endpoints consist of 1 or more clusters, and clusters consist of a set of attributes, commands, as well as events. So for my bachelor thesis, what I initially had to do is I had to create a theoretical mapping between the semantic definition format as well as the Matter data model. I achieved this by using a combination of direct and indirect mapping. As you can see in the table shown at the current slides, these were some of the concepts that I was able to directly map from the metadata model to the semantic definition format and vice versa. But there were also a few informations that I initially had to process from the model in order to be able to map them to the other side. So yeah, based on this initial theoretical mapping between SDF and the metadata model, what I did is I implemented a conversion tool that is able to convert between the two. For SDF, we have as an input for the conversion tool a SDF model as well as a SDF mapping, which will result after the conversion in optionally a device type definition as well as one or more cluster definitions. Device type definitions in this scenario are definitions that define an endpoint. If you think back to the slide on how the metadata model is structured. For the meta side, we have also optionally a device type definition as well as one or more cluster definitions, which will get converted into a SDF model as well as a SDF mapping by the conversion tool. So what I've also brought is a quick little demonstration, a quick little example conversion that showcases conversion from SDF to Matter. On the left side, we have a simple SDF model. Do note that this is missing some meta information that was made to simplify the slide. Also, it is missing the necessary mapping file, but that should, for this example, only contain the IDs for the meta ecosystem. So on the left side, you can see a simple SDF object, a switch that has a SDF property, as well as 3 SDF actions. And this gets converted by the converter into the cluster definition that you see on the right side of the slide. The SDF property gets converted into a meta attribute, and the SDF actions get converted into fitting commands. In conclusion, what turned out in the end is that SDF, the semantic definition format, was sufficient to contain the necessary information from the metadata model and enabled a comprehensive mapping between both of them. One thing that was really important for this mapping was the SDF extension of a so-called SDF mapping, which enabled the export of Matter ecosystem specific information into an additional file that is not relevant for other ecosystems. Based on the before mentioned mapping, I was able to successfully implement a converter that can convert between the semantic definition format as well as the metadata model. And finally, I was able to integrate the concept of such a semantic definition format converter into the meta concept of a bridge. But what is a bridge? A new concept that I'm bringing up right here. A meta bridge is defined as part of the meta specification, and it is a device that has additional capabilities that enable it to provide functionality to bridge between, on the one side, meta devices and on the other side, non-meta devices. So what I did is I took the idea of a SDF converter and used SDF as an intermediate to, on the one side, have the metadata model, and on the other side, have lightweight machine-to-machine. And what I did is I integrated such converters into such a Matter bridge. And by doing that, I enabled the Matter bridge to, at runtime, generate for the lightweight machine-to-machine devices a lightweight machine-to-machine representation of a Matter device, and on the other side, generate a Matter representation of a lightweight machine-to-machine device. And by generating these representations, I was able to enable bidirectional communication between Matter devices and, in this case, lightweight machine-to-machine devices. To prove that this concept of a integration really works, I also built a little demonstrator that implements the before mentioned Matter bridge. On the left, you can see a little overview of the networks, how the devices communicated with each other. And on the right side, you can see the core part of the demonstrator, which were the microcontrollers. The black microcontrollers were our ESP-based, ESP32-based expressive microcontrollers that were running Matter-compatible firmware. And on the right side is the non-Matter microcontrollers. Yeah, and that's it for my quick little demonstration. Thank you very much for your patience. If you like to get some more informations about what I did, especially since I really only scratched the surface of what I did as part of my bachelor thesis, I have a link to the repository for the SDF to Matter converter. This includes a little wiki page of the demonstrator, how the demonstrator works, how you can build the demonstrator. But do note that this wiki page is currently in development, and I will probably finish it over the next few weeks. And also, if you want to know a little bit more, especially about the theoretical backgrounds, like the theoretical mapping between Matter to SDF, my bachelor thesis should be to be released. Thank you very much.
Thank you, Niklas. It's probably worth mentioning that during the hackathon we played with this a little bit. I think your thesis is in German. Is that, do I remember that correctly?
Yes. Yes.
So you have a slight head start if you're in German. Otherwise, you need to use ChatGPT or some other translation too. Thank you very much. Questions? Comment from Matthew on the chat. This is so cool.
Yes, thank you, Nicholas. Really interesting work. So just on the top of my head, have you contacted the people at Matter to discuss with them at some point? Because I think that would be really interesting to see, you know, if they're open to actually integrating this kind of work directly in you know, in their workflow. So that's like just a simple thing. And then how difficult it was to map to use the SDF format to map it to lightweight M2M. Like if I want to do the same thing to map it to Yang, let's say, would it take me a year and or is it like a week of work? I don't know.
Yes. So for the first questions, I've not yet contacted the people behind Matter, but I think for the future that would be really good idea, especially since they're part of the data model of the underlying scripts that were used for the data model, and also a schema for the definitions. They are all currently missing, so that will be probably pretty interesting to communicate with them. And for the second part, the SDF to lightweight machine to machine part was not from me. That was something that was already existent and that I just used for my bachelor thesis. For the other part, for the non-Matter devices, But depending on the complexity of the data model that SDF will be mapped to, that's really what determines how complex this mapping is. For example, the matter data model was pretty complex in the sense that the specification was also pretty complex and at some points not really clear. So it depends on the complexity of the other data model on how long such a mapping will take. But yeah, realistically, it didn't take me that long for this mapping, about 1 to 2 months.
So we're running a little late. Matthew has in the chat, can we see a live demo soon? It seems to me we probably want to allocate a specific event for playing with this, so the chairs will check how we could do that, in particular at a time when Niklas has finished the wiki for the demo and maybe release the bachelor thesis. That might be a good time to do that. So thank you, Niklas. This only was a teaser for something that I think we will be chewing on for quite some time. And Matthew volunteers to bring the lightweight M2M toys. Okay, so thank you, Niklas. I think we need to move to the next item on the agenda. Yes, how do I get rid of... Okay.
Perfect. So I guess I'm audible.
Yes, we can hear you.
Perfect. So I'm just waiting for the deck to be shared. Okay. There we go. So I'm going to just start right away because I think we are running late. So good morning, everyone, or good evening, wherever you're joining from. And thank you, Chairman, for giving me this opportunity. So my name is Manoj Gudi, and I'm going to be talking about this draft, which we've been working on. In fact, some of the co-authors are there, physically present. Laurent, I can see Alex as well, and others. So in case if I say anything wrong or anything dodgy, feel free to catch them in person. So anyway, so we'll go quickly on this. So what are we trying or what are we claiming here? So the thing we are claiming is if SenML can be Yangified, or if we can have a data model for SenML in Yang, then when we actually encode it or when we actually serialize it into CoreConf CBOR form, it is very similar to CBOR SenML form. Okay, so there are a lot of acronyms, and we'll go through this bit by bit. But what we are trying to say is basically the structure of SenML is very similar to CoreConf, and there are some advantages to this. So before we go talking about this in detail, let's quickly go through the acronyms so that everyone is on the same page. Most of us know what it means. So Yang is Yang Data Modeling Language. So the relevant RFC I mentioned. SenML is the sensor measurement list. So this is a specification typically used to send telemetry data. CBOR is concise binary object representation. Again, it's a serialization format which is very concise and terse, and it uses something called as a TLB format. CoreConf is the co-app management interface. It is similar to RESTconf and NetConf. Yang SIDs are Yang schema identifiers. For some of the string identifiers in your data, it is advantageous to standardize them using unsigned numerical integer. So that is what Yang SIDs are. Okay. So moving on, why are we suggesting this, or what is the whole motivation of doing this? So one is since SenMLs are typically used for constrained devices, we need to reduce the payload size as much as possible because these are really low and lossy bandwidth sometimes. And the better defined data model for your application, so it's more advantageous for you. SenML does have a concise data definition language, but it may not be enough because it's not rigid enough. a Yang data model actually helps you further. So you can have certain constraints, you can have a more complex relationship, you can model more complex relationship between your data nodes. So Yang data model should help, especially when you are writing your own application. What we also claim is that CoreCon format may be more efficient for certain identifiers in SNML. You can actually have a SID, and you can standardize those, which can give you more savings. So the whole process is we build the Yang model, so which is what Carsten also mentioned in his slide. So we have information model, and then we serialize it into CBOR. So this is what the process looks like. And then there are advantages that we can, we can leverage the existing Yang models. We can also standardize identifiers, and there is a very rich environment around Yang. So we have tools such as YangLint, Pyang, PyCoreConf, so on and so forth. So how does it work? So I won't go into the detail because that's in the draft. But what I can do, what I can show you is that SNML structure is basically into base fields, split into base fields. So the base fields are basically fields which are common to your data model or common to your records or measurements. So this can have like base units, base name, yada yada, and this can be, although these are optional, they can be modeled as a leaf node, and typically the types are number or string. And we can also add constraints such as base unit must be in one of these or must have one of these units. So accidentally, if your data is using a unit which is not standardized, your lint will throw an error. Then you can model also regular fields such as name, time, unit, value, which is usually a choice type. So you can model into an equivalent Yang choice, which can be modeled as such. Okay, so once we have actually done a sort of a Yang model for SNML, and this is what the hierarchy looks like. So all of your SNML fields can be modeled into Yang as such. Okay, so one of the things which we should be aware of is that SNML has a very well-defined definition, has a very well-defined rule for encoding into CBOR. So in RFC 8428, you will have that, okay, if your data contains a key name, it has to be encoded into a number called as, or into a key with label 0. Similar for base name as -2, base time as -3, so on and so forth. Now we have to remember that the CBOR label for n is 0. Now this becomes a bit of a problem going forward when we are converting that into a CoreConf encoded format, and we'll see why in a bit. So this is the whole process looks like, as I said. So we have Yang model for SNML. Then we generate some identifiers for these SNML identifiers or SNML keys. Once we have sensor data, typically in SNML specification, we convert that into, or we transform that into CoreConf format, and then we serialize it into CBOR format. Moving forward, this is a quick step-by-step demonstration of how CoreConf actually transforms your data. Doesn't even have to be SNML. So if your data on the left is a JSON format, as I said, you have Yang identifiers assigned. Sorry, the Yang identifiers are assigned a numerical IDs such as 60,000, 60,007, and then we create SIDs for them. And then we substitute these SIDs for these string identifiers, and then we finally delta encode them. Similarly, we can do for SNML as well. So we have SNML JSON. We assign them identifiers. But here where the trick is, instead of actually giving them random SIDs, we can encode these numbers or the SIDs in such a way that the delta will be conformant to the SNML CBOR label, which we saw earlier in the slide. So that way, you will have your CoreConf format, which sort of conforms to SNML CBOR specification when it is serialized. Okay, yeah. So once we serialize into CBOR, you will see some module identifiers, so such as 60,006. But if you ignore that number, the rest of the payload or the rest of the data conforms to the SNML CBOR specification, which is quite advantageous for us going forward. So what are some of the caveats, or what are some of the hacks we had to do that for generating this CoreCon CBOR specification, CoreCon CBOR encoded data? So one is that as we saw earlier in slide 8, the label for n was 0, and this becomes a problem, because to get a delta of 0, you have to break the essential principle of Yang sets, which is no two sets can be the same. So we have to break that so that we get a delta of 0. Now this is a really unwarranted, or rather this is really undesirable. And obviously there has to be a better way of doing this, and we can see that going forward, how can we do it. Instead of actually relaxing one of the constraints in CoreConf, asking them to have non-unique SIDs, what would be better is to have a non-zero label for n in SNML going forward, if that's possible, because 0 has a semantic information in CoreConf domain, which means that the identifiers are the same if your delta is 0. However, the labels in SNML, they don't seem to have any semantic information, as much as I understand. Okay. Second is our Yang model for SNML. It's not the most optimal. We can certainly add more constraints to it so that it is more conformant to the specification, which is 8428 for SNML. Then there are other constraints as well, which we can add in Yang, which going forward, which is some of the leaves, such as V, VS, VB, VD, must be optional or can be optional if a leaf some S is present. So again, these constraints I haven't added to the SNML Yang model, and is something we can work in the future. What are the opportunities going forward? So as I said, the Yang model is not the most optimal. So we can sort of definitely work on the SNML Yang model, the Yang model for SNML, which I have been described in the RSC. And this is what we wanted to sort of propose, which is a bit controversial as well, which is can we have a non-zero CBOR label for SNML, especially for the field N, where it doesn't seem to have any semantic information for the label. What are the benefits of it? So once SNML Yang is can be easily, once SNML Yang is perfect, or at least usable, it can be easily integrated with your data models which are in Yang, so that in any environment such as netconf, restconf, if your data model using Yang, then you can actually make sense of the SNML data, and it can also conform to the SNML decoders, which would be very advantageous. So a little bit of work, but you will reap a lot of benefit without changing any of those existing decoders. And going forward, there are some identifiers in SNML which can be modeled as identity refs, but again, this is an opportunity. I would love to have some feedback on it, how to do it, go forward. Okay, so instead of talking about it, you can actually play with it. So this is a generic website. You can go on coreconf.manojgiri.com. On the left, you have the SID database. So you basically paste the SID for your Yang data model. Now this can be generated using Pyang. There is a SID extension, argument which you can give, and then the range, and it will produce a SID for your Yang data model. And on the right is the instance of your Yang data model. So this is what a SNML model looks like. SNML data looks like. So if you paste these two information on your on this website, and then click on the SNML, click on the transform, then it actually generates the equivalent CoreConf data. And as we can see on the right side, if we ignore the 60,006, which is a module identifier, this looks very similar to SNML CBOR encoded data. So that is what we wanted to sort of present as well. And then there are links about it. In fact, if you go in fact, instead of doing that, you can actually click on the SendML example, which is a short link, and it will automatically fill these fields with the data. And you can just play around by clicking on transform to yield this representation format. And this is how it looks in CBOR after serialization. And it also shows that, okay, because we are using core conf compared to the JSON, SendML JSON, the core conf size is only about 104 bytes. So we achieve about 27, 28% of compression. Yeah, I guess that's about it. And I'm open to questions. Thank you.
Thank you. Questions? Yeah, so we don't have a lot of time, but
I'll make it quick then. So what I don't quite understand is like why does this sit on top of the data model as we've talked about before of SendML and not the information model? So I think that if you go back to page 7, the constraints you're describing, they depend on, was it 7? Oh no, sorry, forward a bit. Where you limited something to kilogram or some other unit.
Okay.
That depends on that being expressed as a unit, but it could just as well be expressed in a base unit, and that's a conversion that a SendML producer can basically do, relying on SendML's equivalency. But whether any constraint that you put there is kind of in the base unit or is repeated in the units, I think that's something that should be considered here, that to maybe start working on the information model and not on the data model. Yes, I think this makes the serialization equivalence harder, but I'm doubtful that this holds because kind of we can't just change this number 0 away from that easily. So yeah, that's my 2 cents. Thank you.
Okay. So just 2 cents on it. That's an interesting proposition. We can actually talk more on it. I would love to hear any alternatives of how we can model this. You can also take a look at the whole Yang model and then propose some alternatives. But what we are trying to do essentially is that to have as rigid definition as possible for SendML, which can actually help going forward when you're building an application. So sorry, Alex. Yeah.
Yes. So very short one, because we had a discussion at some point that you can actually express the n. I mean, because you have like this question of expressing with because the label is 0, that you can actually send it as a string, and so all the others can be integers, and just the n will be a string, and it's like 1 byte. It's 2 bytes instead of 1. So then it will have be completely equivalent.
Yeah, so that's a very interesting hack. So what Alex basically proposed is, instead of sending a 0 here, we just send a string key or a string identifier n, and then temperature. So it is consistent with Yang specification. Sorry, I think it should be CoreCon specification, my bad, which is that it can have a mixed match of numerical identifiers as well as textual or string identifiers. However, I'm afraid it breaks the SendML CBOR specification if my interpretation of the section is correctly is correct. So again, happy to discuss more and debate more offline.
Okay, thanks. Yeah, I think this is actually pretty interesting, and I kind of like the fact that like a very minimal addition can make it like look Yang and SendML the same. I think that's some value on it. I was originally a bit wondering about this work, but now actually when I understand it better, it's more interesting. And I think we need to have a follow up on this. And maybe one quick one that, I mean, Chris was already kind of referring to, that N and BN can often be used interchangeably if you have work record by record. So that might be actually enough to go around the 0 issue. But we could take a closer look at that in a follow-up. Thanks.
Okay. Yeah, that's very interesting. Thank you.
Thank you very much.
Thank you.
Both topics.
Yes. Okay, so we're leaving the information modeling part and going to the security part.
Hi everyone, this is Marco. This is a very compact overview of components we've been developing in the ACE and core working groups for secure group communication with co-op. And I just have to quickly mention three pieces of background that are going to recur over and over in this presentation. One is co-op. I believe most of you here are familiar with that, but it's RESTful web transfer protocol intended to be feasible also for constrained devices. Main things you have to keep in mind about co-op from here forward is, some relevant extensions for it, mostly observe and blockwise from entity transfer, is native support for intermediary proxies of different kind, and it's native support for group communication, the main thing of this talk. And the original idea to use DTLS to provide communication security at the transport layer with the limitation that security will terminate at an intermediate, and it cannot provide protection in a group communication scenario. Oh, the transition is a bit slow.
Sorry.
Yeah, on the latest bit I mentioned for security, OSCORE is the other background item, also developed in the core working group. And it's a security protocol to protect co-op messages end-to-end between the origin client and the origin server, also in the presence of even untrusted intermediaries, still leaving them able to perform their intermediary tasks. It's pretty lightweight and compact, mostly because it builds on COSI and in turn, of course, in CBOR. So you really achieve end-to-end security between the true data producer and the true data consumer. And third, the ACE framework for access control, developed in the ACE working group. Think of it as the adaptation of OAuth for the Internet of Things. And the gist is that you have an ACE client that wants to access protected resources at a resource server. And in order to do that, the client obtains an access token from an authorization server expressing access rights that the client has at that resource server. So the token is uploaded at the resource server. In that process, the client and the resource server establish a secure association to securely communicate from then on. And well, after that, the client can securely access the resources at the resource server according to the access rights specified in the access token. And details like communication and security protocols are supposed to be defined in separate specifications called profiles, like the OSCORE profile that consider OSCORE a security protocol for that. Okay, about group communication in itself, it's simply a quite intuitive paradigm that bottom line is about improving performance in terms of latencies and hovered mostly on the client side. It's really about a client device sending a message intended to multiple recipients that can be, in fact, delivered at once, typically, but not necessarily over UDP and IP multicast. So the core working group produced an RFC 7390, an experimental RFC back then. It was experimental also because the picture was not fully completed back then, and there was especially not a security solution doable for group communication. Things happened since then around co-op also in terms of security, and that's why that work is now in the process of being revamped, and I'll come back to that in the next few slides. Some typical use cases that benefit of this communication model, these are just relevant examples, of course. Lighting control is the cliche use case, and it's just a special case of something broader, like automated building control, where you can think of a switch on and off or control a bunch of devices that you may have grouped somehow, like in the same room, corridor, floor, whatever, or a totally different category, software and firmware update distribution to the same set of devices at once, or a variation of that, reconfiguring those devices with a new set of parameter values. Or you can consider something else yet, where, for example, you want to distribute a la PubSub the same data and content to the same set of subscriber devices. So let's make our sandwich. This is pretty much the list of components you need to consider to make it. You don't have to use all of them necessarily. Some are pretty much a must, like the ban, I suppose. Otherwise, you can skip some of them if they're not really pertinent to your setup or what you need. But you can kind of split them into two subsets: operational for the actual secure message exchange, and management, for example, for the sake of key distribution and setup. Don't focus too much on the details. They're not covered here in the interest of time, but you have all the references at the end of the presentation. Those components are supposed to be used, of course, in a setup and system lifecycle in this chronological order. So creating and configuring the groups and the security groups, first of all, for the devices, discovering those groups and joining them, and as part of the joining process, obtain the key material to securely communicate in the group, and finally, as group members, communicate in the group with the other members. Pedagogically, I think it's better to go through the components actually and going through them in the reversed order compared to what you see in these slides. And at the end, when we have seen all the components, we can go back to this life cycle in the right chronological order, having our components in our caches. So let's go to the building blocks, starting from the operational component ones. Group communication for co-op in itself, as I mentioned before, has been revamped starting from the old experimental RFC, but in the light of developments that have happened since there, the focus is still mainly on UDP over IP multicast, and other possible one-to-many transports are out of scope, at least for the document. But we are covering a number of aspects that need to be elaborated about co-op group communication as the different type of groups that can be combined with one another, approaches for naming the application groups in particular in URI, and mostly processing rules on the client side for the sake of a longer retention of the co-op token, for a longer time window during which the client is supposed to receive multiple responses to a same request, all paired with one another. And we are also in this process updating the model for caching and validating responses, especially with proxies in mind. And Grupo Score is considered as the security protocol to protect communications in this setup. This setup can be particularly enhanced by the introduction of intermediary proxies in between a client and the servers in the group in order to address a number of issues that are quickly mentioned in the previous document I showed and are much more elaborated and addressed in a dedicated document about this topic. It's really mostly about a dialogue that you can have between the origin client and the proxy, where the client can instruct the proxy to perform this group forwarding in the first place, and for how long the proxy is supposed to accept responses and forward them back to the client. When doing so, the proxy is supposed to further help the client, specifying into each response addressing information pertaining to the server that originated the forwarded response. And by following those instructions, the client will be able to possibly follow up with that exact server directly, if possible, or again, through the proxy. Thing here is that the proxy is supposed to recognize, identify, and authorize an exact client before, especially forwarding a request just like that to a group over multicast. So you need an additional secure association between the client and the proxy. There were already means to do that. More effectively, it would be good to rely on OSCORE again for that. And that's yet another item at the end of this slide for which I have, in a few slides, some more dedicated information. And Group OSCORE is the main item here in terms of secure communication, really. It started reasonably from the OSCORE security protocol and standard, and it built on it so that it could essentially be extended to cover also the group communication setup, but trying to reuse as much as possible of its philosophy, mechanics, and inner building blocks and so on. But fundamentally, the idea is to fulfill the same security properties of OSCORE, just in the group communication setup. The key management part is taken for granted, at least by this protocol, but it's covered by other means that we'll see anytime soon. Once in the group, anyway, a group member has both some material commonly shared with all the other group members, out of which can derive individual material actually used to protect the messages. When it comes to the actual message protections, we always ensure source authentication. That's possible in two ways, called group mode or pairwise mode, that you can decide to use on a per message basis. Simplifying things a bit, the group mode is essentially intended for one-to-many messages, like the request sent over multicast, and these messages protected in this mode are signed by using the private key of the sender, essentially. Well, the pairwise mode instead is intended for one-to-one messages, like the corresponding responses. They don't need to be signed, but yet they display source authentication since they're protected with symmetric material that is derived out of the authentication credentials of the two exact communicating group members here. This builds on an entity called group manager that is responsible for the group and especially for provisioning the key material and driving the joining process. And this will come back later on. This is just a visualization of what I've said. It's just an example, of course. Here you have a very small group with the client sending a group request over API multicast, protecting, say, in group mode, so for all the servers to decrypt and access. And then 2 of the 3 servers respond with an individual response, say, protected in pairwise mode, so that only the client can decrypt that. I mentioned before that in this particular setup, again, with the proxy aiding the group, you need a secure association between the client and the proxy, and that due to a new work we've been doing also in core, that association can, again, build on OSCORE, which is nice because you are supposed to have group OSCORE end-to-end in the first place, and in the interest of code reuse, simplicity, and so on, it's good to have OSCORE also in that particular leg client proxy. So originally in the OSCORE specification, this wasn't allowed. There were not even use cases really to justify any of that. Now there are. This is just one use case, the proxy setup I mentioned before. It's essentially possible to have now OSCORE at proxies and between the client and the proxy, or the proxy and a server, or between adjacent proxies in a chain. And as you can see in the figure, that also has a side effect of protecting, at least in the leg client proxy, the same message twice, like an onion. And in fact, this can be used as a building block for building a sort of onion routing. That is the topic of the next presentation. On more advanced communication paradigms that you can in turn build out of this, there's an extension for co-op, Observe, where a client can fundamentally subscribe to a resource at the server in order to be automatically notified with notification responses when the resource representation changes. But you may have now an interesting setup where multiple clients are all observing the same resource at the same server. What you normally do would be for the server to individually send one notification per client separately. In the interest of efficiency, we are designing a way for the server to instead react by sending just one notification over multicast to all the observer clients at once. Essentially, it's the server that takes over control of that group observation on behalf of the group. And the artifact is for the server to prepare really an artificial observation phantom request that it sends to itself, not on the wire, just internally. And if any client comes to the server asking to start an observation the traditional way, the reaction of the server will be an error response saying, I have something better to offer you. And that offer is all the information that the client needs to, in turn, locally set up what is needed to receive correctly and process correctly the notification of a multicast sent to all the clients at once. And of course, you can still use group OSCORE end-to-end between the server and the client to protect the notifications. The last operational component, I think, originally OSCORE prevents the effective caching of protected responses at proxy. The proxy can technically store in the cache the response, but then 2 clients starting from the same plain co-op request would produce 2 different OSCORE protected requests. So you don't have a cache hit. Practically, you don't have caching. Building on group OSCORE, we are restoring this functionality instead. And any 2 clients in the group without additional communication are able, starting from the same co-op plain request, to produce the same deterministic protected response. So as you see in the figure, a first client would have the first request going all the way to the server and then the response cached and then back to the client. But then the same client again, or a different client starting from the same plain co-op request would produce exactly the same deterministic protected request, produce a cache hit, and be served from the proxy cache. This is also current proposal in core. So moving to the few management components instead. The main thing is the joining of the security groups and the key provisioning for those, and that builds on the ACE framework. It's just a simple mapping if you think about it, and it can be authorized. So you want only authorized nodes that are supposed to join a group to actually become members of those groups. And here the ACE client is going to request an access token as an evidence of its rights to be a member of a group, upload the token to the resource server, which is here the group manager, And if everything is fine, there is an exchange of join request and response, with the join response containing the key material that the EA's client needs to be a member of the group that can, after that, communicate with the other members of the group. And that would solve first access control problem, access control for the sake of entering the group and obtaining the key material. And that's exactly where a second dimension of access control starts, totally separated from the first one in general. And that's about a group member obtaining an evidence of its access rights, again, as an access token in the ACE framework, to prove its rights to access protected resources at other group members acting as resource servers in that respect. And for that, in the ACE working group, we are defining a new profile of ACE based on Grupo Score as the security protocol to use for that. And this is also aligned with the zero trust paradigm from NIST, where you're really not supposed to trust things by default, and you are supposed to enforce fine-grained rechecks of access control rights. I've basically considered so far a sort of interface that the group manager provides to candidate group members for joining the group and obtaining the key material. There's also, in parallel, at the same group manager, a different, again, RESTful interface intended for administrators instead, that are, again, supposed to show they're authorized to do any of that, again, building on ACE. But this figure summarizes the interface and the API, if you want, that the group manager can provide to administrators that are in the position, if authorized, to create a new security group or delete it and configure, reconfigure it. This is just a summary of the available methods. This is also a proposal in ACE for which there is a parallel document specifying how this can happen specifically using Coral, which is also a self-standing work in the core working group. Finally, about discovery, you may deploy a device in general, or even very early in particular situations, even before the group manager or before the group is created. And that device, for a number of reasons, may not have enough information to understand exactly how to proceed, which group manager you should talk to join which group. That can be solved by using the core resource directory. And in particular, the group manager can register itself to the resource directory, and right after the links to its own resources that the device is supposed to access for joining a group, like we saw before. And well, after that, the device can just look up those resources at the resource directory, finding the group manager, the links of the group manager to join the right groups, and even the properties of those groups as target attributes of those links. Now we have all the ingredients in our caches, and we can revisit the life cycle in chronological order. It's all supposed to start with an administrator creating and configuring a group at the group manager, and then registering itself and the links to its own join resources at the resource directory, so that possibly a device can take advantage of that and discover the group manager and the links to the join resources. After that, the device is supposed to obtain an access token to join the groups of interest, interact with the group manager through the join process to become a member, and obtain the key material to securely communicate in the group, which is what happens at the right of the slide. Secure communication can happen in the group with Grupo Score, possibly adding on top of that access control with respect to the resources at the group members. We have also surveyed a number of variants of group communication. The leftmost one is the simplest one, essentially group requests to which the servers can individually reply. The middle one is a variant of that, where you have an aiding proxy of some kind deployed in between. And the third one is quite advanced, and it's in the interest of having an efficient group observation, fully managed by the server that can send one-to-many notifications over multicast. To nail this down to earth, really thinking of use cases itself, at the interim meeting of T2TRG in Paris in May, I had a presentation linked here that is all summarized in one slide here. Some building blocks here can be nicely combined to efficiently distribute in a group of devices the same software and firmware update pretty efficiently, building on, well, group communication for co-op, Grupo Score for protecting end-to-end distributed update, proxies for the sake of caching and more efficient retrieval, and for blockwise transfer, considering different block sizes on one leg towards the server and on the other leg towards the devices that wait to be updated. This is just all the list of references for all the components we've gone through. And I stop here. The slides actually don't finish here. It's up to you. There's some bonus material after this if you want to see step by step how you really add those components in order from nothing at all deployed to have a full-fledged group communication setup. Thank you very much.
Yeah, that was amazing, in particular doing this in this time. So I'm going to extract this talk from the YouTube presentation and put it up on my channel. And normally when I put something up that I'm moderating, I speed it up a little bit. In your case, I will slow it down a little bit so you can follow it. We don't have much time for questions, but maybe one or two.
Hello, Dirk Kutscher, HKUST. Yeah, great work. This seems relatively intricate. Have you done a security analysis? So what could go wrong?
Well, not a formal analysis, I have to say, for this block. There's a lot of security considerations for many of those. In turn, building on considerations of the building blocks they build on their own. It seems solid so far, and time will tell. Okay, thank you.
Hello. Yeah, I'll just do this way. Given all those pretty blocks, we've played around a bit, and I think those blocks can be assembled into something that looks a lot like Tor, the onion routing. So let's have a look at how those parts come together. Just for a quick overview, so I've presented this like a year ago or so in Prague. To give a rough overview, the idea is that a client and a server can interact using co-op with end-to-end security without either party knowing the network location of the other. So the server hides behind this proxy, and the client, like on the right chain, and the client hides behind the proxies on the left chain. And neither of them trusts any particular of the proxies, but they trust that a sufficiently long chain of hops in between that all promise to not to not reveal the client's location. As long as one of them holds their address stays secret. So this can be built up by many building blocks, and I've gone through a few of them and classify them into like, what do we have here, what is already published, what is quite mature, as in it's a working group document or it has been around for some time and it's not really changing a lot, what is currently being worked on. The asterisk indicates what do we have to do just for this work, and kind of my goal here shows that there are not many asterisks in there, and not all the classifications are completely like. This is just a rough thing. So sometimes there's a question mark. So what do we have? Marco already introduced many of the building blocks. OSCO and OSCORE comes in here. Advertising proxies is something that Marco has not talked about. That is work in core about how can we tell that for a particular URI there is not just kind of the one trivial address that you can resolve this to, or maybe you can't even resolve this to an address, but there are still kind of, you can still appear, hey, like there is something available. I talk a bit about naming by hashes, which is something that also has other use cases and work. And then there's also the resource directory in which we can register things. So just as Marco showed for discovering groups, you can also discover like things that don't trivially resolve to an address to connect to. One part that gives the thing the name with the onion routing is other layers. So in OSCORE, the way it looks like is you send a post request to some proxy, and the OSCORE capable proxies document allows doing 2 of those in a row. But really, the proxy cannot know whether inside the onion there are other layers or not. So just because we have 1 hop already, we can establish always one more, so we can basically layer this infinitely. And The limit is probably the message size. Rough ballpark thing, you add about like 14-ish bytes to a request for every layer you encrypted with. Might be a few optimizations even in there if you don't like need each of them at the same security level, but that's kind of, you can build up a few layers in that without like changing what you can put in the packet and the rest. The way this is this is set up here, and this is something that we don't kind of, that is not described anywhere in particular, but I think that kind of already follows, is that you can do ad hoc to establish your OSCO context. That is something well established, and combining with proxy OSCO, of course. If you do ad hoc with any peer behind a proxy, you set you have an OSCO context with that proxy that goes through there. So that's the way these layers grow. So from a client's point of view, oh, okay. That's just a slide that I've kind of failed to prepare. From a client's point of view, what you do is kind of source routing. So you put all those addresses in the different layers, and as the layers are unwrapped, the proxies all of a sudden discover that, hey, now this is a message that is on for that proxy. So P3 sends it over to P6, and then P6 decrypts it, says, hey, kind of, this is a request for P1, and so on and so on. So that is based on building blocks that we already have there. One thing that is out there in use on the internet, and especially on Tor, but that we don't have a good basis to stand on yet, is naming things with hashes for a host component. So the way this is currently suggested in transport indication, and that's one of the more immature parts of that specification, is to describe a name pattern that is kind of compatible with the general style of how we name things, but does not resolve through DNS, but indicates that whenever you see something that ends with service.arpa, this does not immediately give you a way for solving, but this tells you that if you did a request on that, if you tried to resolve, in this case, for example, a service B, a service B DNS request, then what you would get back is a service parameter ad hoc credentials that has this value encoded in base 32, because that's kind of the best thing we can do for binary data. And what is in that name is a KCCS, which is a CWT claim set, which in essence is a raw public key. So what this name says is that anyone who can prove possession of that key is eligible to serve as that, to serve resources under that name. But that is not something that we only need here. So we don't need the full combination as it is printed out here, but this that we could do this follows from the need of expressing SVCB in literals, because kind of future transports will not, we can express IP addresses, but not SVCB results. So that's a topic discussed at length in transport indication. And the need to provide KCCSs is something that comes from discovering DNS over CoAP, because the network might tell you, hey, there is a CoAP server. This is your this is the key it's supposed to present. Please talk ad hoc to it. So we already need those components. And I don't have a time. Kind of, how am I time? Do I need to hurry up, or can I?
A little bit.
Okay. Okay. So one more component that we have here. Okay, then I'll just skip things here, because yeah, we can register our addresses.
Sorry, you have like 5 minutes.
Oh, okay. Sorry. Yeah. At any rate, when we so the client route to the middle proxy is relatively easy. It's like kind of source routing. In the other direction, in the end, what the server wants to do is register itself in some global in something globally reachable. So it puts its address into some resource directory registration. The resource directory is already well specified, and it usually infers the address that the server is available on from where it comes from. But that does not work when you're going through proxies. So something that we've
we're describing so far is that we add another option that allows to co-op, and that is something that's also used already in group com proxying, that says, if you're talking to me, please use that host name so that I can understand in which role you're talking to me. And the very same option is something that we're using in the setup of a registration at resource directory that traverses proxies that we add on each hop, or that a proxy adds in the hop, so that when finally there is this role reversal happening, the message can come back in the other direction. And this is very similar to something that is happening in ICNG, in ICNRG, where that Dick has worked on, where we send a request and we provide like some breadcrumbs that can be consumed by requests in the opposite direction in order to get a request that's coming from the party that was originally the server in the role of a client back to the original server. So this is outlining the full sequence of steps that we are doing. So we do build up from the server onto a proxy that will be eventually the public address. We establish kind of ad hoc all the way down, and then we use that co-op option in the request to in the request that is being sent to the resource directory hop by hop to state that, yes, please send data back to me, and also allow this role reversal in the first place. Whether those options are really conceptually even essential is something that we are still looking into, because it may well be that we can use other components that are in there already, like the association between an ad hoc raw public key and a name, to simplify things on a conceptual level. But from a practical implementation point of view, I think that these options are something that we would like to have in there. So we would have to specify them out for that purpose in full. But my hope is that even those options are something that is merely an optimization for something that is already using the building blocks. So yeah, conclusion here is that I think that the core work and the steps are there to build things that we did not imagine when we started specifying them. But whether this can actually work in practice is something that we are exploring as part of this experiment, and are slowly working towards having implementation so that we can finally, and that is from a draft point of view, the goal here, to roll this out into something that can be an experimental RFC, for example, that describes such a network, and then just gather experience with that, both on the implementation side and on the management side that I completely skipped here. That is about how do we actually find which of those proxies are kind of eligible, and how do you manage that pool of relays or proxies. Okay. Do we have a bit of time for questions if there are any? Okay. Any questions, suggestions?
So when we discussed this morning, one question was, what about the recent attacks on Tor? Have you considered those?
Yes, we have considered those. So one, I mean, in a sense, if the attacker can monitor all the hops, and if the attacker has sufficiently good timing information, I don't see how you get around this. But there are things that we can do here that are that might even be easier to do here than for Tor. One thing is that we can, and that is something that would probably be part of the ad hoc setup, associate security contexts with a timing criticalness. So if a client knows that it has no full urgency, that it kind of you don't get real time, whatever that would mean here, through such a network anyway. But if there is no urgency, a client could indicate during the security context setup that, for example, it has some expectations on the round trip times involved. And then if the proxies have, so the proxies between them also create secure connections. and those they may keep alive. And if given that the clients and servers are constraint devices, but the proxies are not, they might well be send some kind of housekeeping keep alive data. And whether that's just padding or whether that is messages can depend on whether there are actually messages around. So for the sizes of messages that we are considering and for the bandwidths that we have between the proxies, I think it's totally realistic that the proxies might send, like for each connection that they have ongoing, say 1 MTU, one packet per second or so. And if that's just padding, it's just padding. But if a client is actually sending data, it will have a round trip time of whatever the maths work out for, like having that second delay, but maybe they kind of stagger well and maybe they don't, all that way through. And the response will still come back, and then there will be no visible effect other than kind of random data looking differently random. But of course, that has performance implications, and that are things that we'll have to look at in practice whether they can work.
Any questions? Thank you. So we just have to put in the alphas in your slide with things we still have to do, and then we can just offer this as an application.
Yes.
So one other thing that came up this morning was that the draft is currently thin on use cases for this, but I think they are just obvious to us, and we have to write this up a little bit more. Thank you. So the next item on the agenda is Michael.
Was anyone at RIPE last week? No. Okay. It was presented at the IoT IoT working group there. So I'm just going to give you a summary of an effort that's gone on for about 2 or 3 years now at the NIST National Cybersecurity Center of Excellence. I get that wrong every time I try to expand it. You probably know what NIST is. I don't have to tell you, but some people elsewhere don't. There's some words from their websites and things like that. They have a big list of documents that you can consult. The URLs at the bottom. Essentially, this is an effort to bring together industry people who have different secure onboarding mechanisms to provision various kinds of credentials into the devices during onboarding. And there's some big documents there, a lot of details. So what happened? Well, around 2020-ish, there were kind of about some rumors about the effort that came through IETF and other places. They have a process where they put some document into this federal registry notice that basically gives industry players formal notice that this is happening, so no one is surprised and wonders why their competitors are there and they're not. We started in June 2020 with a project launch with a physical engineering day, and people brought, real components. And then had, collaborator calls twice monthly. Various things were added, fixed, extended. There was a lot of document review, like how does this work? How does this work? Do you do this? Are your keys private? What do you need? A lot of learning on various things. 2023, we added this build 5 and 6, which I will talk about very briefly. Right now things, and mostly for them, it's documents are wrapping up. And then there's going to be another engineering day in the winter of 2025. I don't think I'll go. I don't think I'll travel to the US in the end. So what was there? So we had 2 DPP, otherwise known as Wi-Fi Easy Connect protocols. One from Aruba HPE. That was, if you know Dan Harkins, he was involved in that, and a couple other people. And another from Cable Labs, and I forget the gentleman's name, but he would be a well-known person at the IETF as well. They both were doing DPP. Interestingly, they were doing it in ways that wasn't quite compatible I believe going into this that we would have a lot more kind of engineering effort, but it turns out it's quite hard to fix and adjust things while sitting in government lab in DC without necessarily really good coffee or desks or other stuff like that. There. I brought a Brewski implementation, 8995, a bunch of stuff like that. This Romanian company, Kudelski IoT, brought a thread-based system with an application layer onboarding up to AWS. Somewhat not the first day, another group brought another Brewski implementation. Did we interoperate? No, not yet. It is still planned. They were inquiring minds as a Southampton, UK effort. You've seen from some of them at IoT Ops and maybe here and other times. And then we added this other build 6, we called it for a while, factory provisioning use case. And this was about essentially how we got private keys into secure elements in the devices. And there were some efforts to rework hardware with secure elements inside of them from a couple different vendors. That's a bit non-trivial. There's some, non-significant investment of developer time, and unfortunately some NDAs that get in the way of really doing it properly with open source. But we tried anyway. So I have a lot of diagrams in this talk. There's a lot of words in them. Some of these diagrams are actually screenshots out of other presentations, and some of them are SVG files that look different in other ways. But this is the notional architecture, which is that you see it starts with one. Where's the one? One at the top, device manufacturer and factory provisioning. So that's what we're actually dealing with, the factory provisioning. They put something in, you put some credential in the device. And number 2, device ownership and bootstrapping, information transfer. Well, the notion that it goes into a supply chain integration service, and for some of them, the mechanism that's critical for things like Brewski, well, we do that very late binding, for instance, and another way. Device gets shipped to the where it's going to be used. There's some interaction, number 4, number 5, with some kind of a decision control point. It says access point, router, or switch. There's a network onboarding component. We added this continuous authorization service was considered important, and that was the various high level. This is the high level architecture, and then the next slides are how do we all map into this. Okay, and I'm actually I don't have a good slide from build 2. This was a slide from build 1. I like this slide better. It seems more friendly and happy, and there are more pieces in it. But this was the official slide in the document with a lot more words, and you can see things are moved around in different places, and it matches a little bit better the first slide. So there's some back and forth, and I think actually if all you take home is that we had this diagram and that all of us kind of fit into it, that's probably a good thing to bring home. Build 2, oh yeah, there's this diagram, even more words on this. And if you're familiar with DPP, then the concept that we would do QR codes was kind of glossed. No one did QR codes in this space. So I'm not going to go through those words. Build 4, they do a thread onboarding commissioning process. And then I guess a lot of it was about, and I don't actually know the details, which I find very strange, but there was an application layer onboarding process, which some people were quite excited about, I guess, as a conceptual concept. So there's network layer onboarding, which at some level means, type in the Wi-Fi password, right? But ideally, we actually have, we're doing maybe EEP TLS with a real credential. But then what's the next step, right? Okay, so that's great. It gets you onto the network, but how do you feed the data, whether it's SendML or encoded or whatever, up to your collection thing, and how do you do authorization for that? So that's what the application onboarding is. I skipped build 3 because I have more slides, because that's my slide, my thing. So we added build 5, and they decided to implement Brewski for a variety of different reasons. Oh wow, that's really poorly spelled at the top, but they really cared about this continuous authorization service. They did a lot of work in that space. There's an inference engine with a prologue mechanism in there that does reasoning as to whether, for instance, this device was secure when we started. Is it still secure? What kind of reasoning can we do about that? Some of us managed to do some interaction with various secure elements. There was an Infineon, a WiseKey/Seal one, and an NXP one. And as I said, there's I would say an underestimation of how non-trivial that really is to work into things. Doesn't help that OpenSSL moves from whatever it's called providers to engines or engines to providers. I can't remember which way we went from version 1 to 3. My code, for instance, is, has extensions to version 1, and it doesn't work with version 3 for things like that. So this was the Brewski version. How does it work? Well, so create and give it a serial number, and that supply chain integration service, well, that actually is late bound. So it's doesn't actually have you don't actually tell your supply chain what's going on. You keep it in a database, you put it in your MASA. And number 3, there's at late binding time, there's a reach out to the vendor to get a voucher and do this kind of work going there. That was the diagram I created when they first came through. You can see the mapping of what goes on, all the different, RFCs that go into that place. I say the diagrams change back and forth. That's what my network looked like. They said, hey, would you like a virtual machine? I said, hey, why not? It was an interesting effort. Turns out that just by the way, VirtualBox still uses SHA-1, and ESX won't speak SHA-1 anymore, and turns out they're no longer compatible at the OVA level if you deploy appliances. It was really annoying, and there's no good error codes that tell you that that was the problem. Sort of like, well, okay, deprecate it, but gee, they ripped the code out, right? So you couldn't do anything with it. All of this was remote. This is what it physically looked like when it was shipped. I measured the inside of my suitcase, cut a piece of plywood, mounted it all. On the far right, you see there's a USB hub with buttons that turn the power on and off, right? That's useful. And in theory, it didn't work as well as I like, but this is one of the ones that supposedly has real power control. So you can actually turn the power on and off from the host and turn power on and off. And I would say I had a 40% success rate with that. And this is after I went through the 4 of them that I bought that said they were supported by the drivers and other stuff like that. So worst case to worst, you say, hi, I think it was Chris, can you go push button 4? And, something will come back to life when you're far away from somewhere else. It's amazing how big this picture is once you start writing it on, by the way. I had to lower the resolution 3 times, or the PDF one's up, 100 megabytes or something stupid like that. That's an Omni-Turius router at the bottom and a switch and some other things, and that's about it. Factory build demo, we don't have a factory. So the idea was that we would put factory firmware in the form of an SD card into a Raspberry Pi. The lack of Raspberry Pis in 2022 was a real problem. They were, being traded like gold. And then you do an onboarding thing as if you're in the factory, as if you're sitting on a bed of nails kind of test. And then you pull that factory firmware out, which might have some credentials that are relevant to actually onboarding into your certification authority. Pull it out, walk the Raspberry Pi across the room, put the operational firmware in, and then do something, noting that the secure element, which is that black bit on the top, it's still got the private key that you started on the left with. And so that's what we tried to do. And hardware-wise, it's fine. As I said, software-wise, there's still a lot to be done, still a lot to be worked out. Discussions. Anything else? Was that fast enough?
Yes.
Good. I said there's lots of pictures, lots of words in those pictures, and I'm happy to have anything. There's lots of those documents that are referenced are big and long and detailed. and would love to have feedback, even if it's a, what does this sentence mean? It makes no sense to me. They would love all sorts of feedback like that. But I think the real big output is the real demonstration that there really are solutions for zero-touch onboarding. Unfortunately, there are several. XKCD 927 applies. But I actually think that we have some potential convergence between EMU, PAKE, QR code authenticated TLS, which is a document from Owen and Dan in, I think, the TLS working group, and Brewski and things like that. We actually, I think, could get convergence of some of these things. At least it would be easy for a device to support 2 or 3 of them at the same time.
Thank you very much. Very interesting, and a very short question. I maybe answered it during the presentation. Of all the things that you presented there, the documents are public, right? We can go and find them.
So the result document, which is this URL back on page, I don't know, something back here, this one at the bottom there, that points to all these documents. They're all public. Many of them would like comments, draft. They'll get published by NIST as public documents. There's many real deep technical contents in there, how-to guide, really, blah, 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 blah. This is what happens. And then this packet goes, and then you tweak this configuration file, or, very detailed stuff. You may know the DPP spec is behind a marketing paywall, a marketing wall, which demands IPR. And there's some weird patents out there at DPP, which Wi-Fi Alliance actually was unaware of. And that has actually had an effect on people of, I won't read that document because I'm afraid of those weird patents. Yeah, so, there are IPR issues, but the documents are public.
Okay, so just a short follow-up. When is the next event, or like what?
So I would say it's finished. Okay, I'm surprised we're having a in-person in January, February. I think that might be as much of get this crap out of our lab, take it home, as anything else. So I was kind of expecting that for more than 6 months now. Yes, I think a do-over is in order between pandemic and products not really quite being ready. I would love to have a do-over in maybe 2 years. Maybe someone else would do it, some interop, INRIA kind of thingy, but, whatever. Etsy could host it instead this time, whatever. I would love that. Anybody else? Lunch?
Alrighty. Thank you, Michael. And yeah, I think we're almost at the end of the meeting, only a few minutes to go. So we do a really quick wrap up here. So first of all, thanks a lot for all the presenters and good discussions here. And as we mentioned in the beginning, these are the summary overview meetings where we actually don't have a chance to go into details. So we'll be setting up some follow-up meetings where we actually do have more time for discussions and details. And I kind of see at least one for the data model part. I mean, we didn't have time to discuss everything. So probably we'll set up a follow-up on that, both on the Matter SDF and then also on the Young NML. Probably the same common meeting. And then also here on the security topics, clearly we're going to need to take a closer look at this. So I think that if you have any preferences on when to have them, when to not have them, let us, the chairs, know. We will probably notify you soon on the mailing list on the logistics going forward. But yeah, I think that's the summary for me. Karsten, anything?
Yeah, I think this was a great meeting, and I think there are several talks that will be referenced by people. Yeah, looking forward to the interims we will generate from this, and maybe a face-to-face in Madrid again. Enjoy the rest of the meeting. And there is an ASDF meeting this afternoon, so if you want to go on that subject, you can do it right away.
Finish on time.
have 1 minute left. We wasted a minute.
I should have followed your example and ran through
Like 5 to 7 minutes overtime, then there's a master.
that.
Yeah, Michael was pretty quick. So that was-
Oh, wow, okay. Yeah, that.
I was standing on the Raspberry Pi the whole time. Yeah. So that's what runs this session. And, I'm lucky that I didn't unplug the cable.
Hello, I'm Carolina, and Eve introduced me.